Hello, CS 1030 students. This week and next week, we are talking about software engineering, which is the process of producing software applications. Software engineering is much different than any other type of engineering. It's a brand new discipline. It's probably newer than most engineering fields, and it's unique because it's only been around 30, 40, 50 years. I mean, people have been designing software off and on since the 1600s, but as a discipline, as something a lot of people are doing, it's a brand new thing. Most of you have had some practice coding, and that should provide some sort of a framework for this lesson and next week's lesson. Others of you have used software. You've used Microsoft Office and you've used Google Docs and you've played video games, and so there should be some sort of a reference here. But as I said, software engineering is not like building a building, and it's not like making a car, and it's not like making a wooden desk or whatever else you might build or writing a novel. It is its own animal, has some comparisons to other types of things that you might create or build, and yet it is a very unique discipline. It's also new, so there's not a lot of theoretical framework, and yet it's been around just long enough now. We're starting to look at how software is made and draw some comparisons with how everybody's doing it. So the first thing you need to know is the life cycle of software itself. From birth to death, you need to know the life cycle that software goes through. I'm going to talk about each and every one of these steps in turn, but there is the list of the steps or stages that a software goes through. If you want to pause this and write these down real quick before we get to the next slides, you can. I'll probably even give you guys a handout with some of the stuff about them here. But step one is project feasibility. This is the birth of a project or of a software. This is where somebody comes up with an idea and they ask the question, is this a good idea? Is this a good software that would help people out? Sometimes this is a user, what we call the end user, and they go to one of their software buddies that they know is in software. Maybe they're not in software, and they go to their friend who designs software and says, is there a computer program out there that does this? Maybe it's a video gamer, and maybe they post on Reddit or on Twitch, and they say, wouldn't it be cool if there was a video game that was like this, that had this type of story or this type of game mechanic? And so they ask the question, is this a good idea? That's the first step, coming up with an idea and asking yourself, is it feasible? Is this something we can do? Is it something we can pull off? Is it something we can make? And is it something that would make money? Is it something other people would find helpful? So that's the feasibility stage. It's just the brainstorming stage, asking, is this a good idea? Second of all, then, if you decide it is a good idea, if you decide it does make money and that it would help people with their life, then you specify it. The software specification stage. This is where we ask and answer the question, what does this program need to do what we want it to do? This is where we say, you know, map it all out. We write the mechanics. Maybe we write what's called some pseudo code, which is fake code, but it's just writing it down. And we specify, here's how big it should be. Here's the graphical stuff we need, the interfaces we need. Here's the variables. And so we just sit down and we specify it. Next lecture will be a lot about that stage and the next stage, which is the design stage. This is where all the work happens. This is where we sit down and ask, how are we going to make it work? And then we answer that question, and here is all the work goes into actually designing it. Here's where we write the code, we design the pictures, we record the audio files, we make the interfaces, and we actually put it all together. This is the most important stage, obviously. Before this stage, it's just an idea. And we just ask, will it work, and what does it need? Now we're actually making it work. Now this is the hard stage, right? Where it just sort of where everything can get really difficult really quick, but that's where we sit down and we actually design it and make it work. Then the process isn't over yet. You think after the software design, we've done it, mission accomplished, we're good, ready to go? No, mission is not accomplished yet. Just because you've written a novel doesn't mean you should publish a novel. Just because you have made a car doesn't necessarily mean that car is roadworthy yet. You might still crash it, right? Just because you've built a house doesn't mean people should live in it, right? So the next stage, it's true of software. Just because you've made a computer program doesn't mean it's a good program, because the next stage is the testing stage, the validation stage. Validate is just a fancy word for asking ourselves the question, does it work? Does it actually work? This is the test where we validate it. If you guys are into video games, you probably know a little bit about beta testing. That's where the video game companies will release their new video game to a set amount of users. You could go online and apply to be a beta tester. Sometimes they'll even give you a little bit of money for it. At the very least, you'll get a free game. The game will be full of bugs, but you'll still get a free game. But this is where you test it. You actually run the program and make sure it works. And note with bugs here. So does it work? Now we validated it, and if it works, we release it, and hopefully we make a lot of money, and a lot of people give us awards and write us nice emails saying this software changed my life, thanks for your hard work. I'm sure you guys write emails like that to all the software developers that have made all the software you use on a daily basis. That was a joke. I know you haven't. For the record, I haven't either. But still, hopefully, you know, once it works, you can release it. But most software is still not done at this stage. Most software, once it's been tested and released, is still not over. In fact, I would argue if any piece of software is successful, that means if it actually worked and solved people's problems and made a difference in their lives and made the developers a lot of money, then it goes on to the last stage, which is called the evolution stage. And that's where we ask and answer the question, what changes might this program, this software, need to stay current? So think about any software that you guys have dealt with. Microsoft Office products, Excel, Word, PowerPoint, they have all gone through evolution. They are all vastly different than they were when they were first released in the early 90s. Microsoft Windows. Vastly different than it was in version 1 or version 2 or version 3.1. Video games even are now evolving. This week I've gotten a little bit of a break during spring break and I've played Final Fantasy XII. I went online and I found that there are 5 different versions of that game. It came out in 2006, and it was an okay game. Some people liked it. It wasn't for everybody. I played through about half of it and moved on. But now I've bought the Zodiac Age, and that's even the Zodiac Age. There's been 3 of those types of that game. So and it's for the Switch. And so any software that's successful will evolve. It will be re-released. It'll be remade. It will be remastered. It'll be redone, and there will continue to be new versions. What's interesting in today's age is that all software is constantly evolving. The other funny thing about Zodiac Age is I thought I had the definitive final version, and yet I turned it on the other day and it said we need to download an update to the game. You need to reset it. So I had to save my file and restart the software, and they installed even more patches, even more updates. Even Windows right now, once a week, it says we need to install updates. So any software that's successful will constantly evolve. So those are the stages of a life cycle of a software. Somebody will come up with the idea and ask, is this a good idea? Then they will specify it. They'll make a design document and plan it all out. Then they'll actually put it together. Then they'll test it. And then if it works, they'll continue to evolve it. Those are the stages software go through. But now, let's talk about software developers and how developers actually bring a software through this life cycle. And because software engineering is so young and so complex, and there's so many different types of software, I think building a cardboard box house or fort in your living room is something entirely different than building a 3-story mansion, right? And yet software could be anywhere in between that. So there's so many different ways to design software. So the textbook has figured out a few, and here they are again. This is another list for you. If you want to pause me right now and write these down, you can. But these are 5 ways that software is usually developed by different teams. So there are different models for how software is developed. I want you to remember these are models. I don't think any software sticks to one of these models entirely through its life cycle. There are differences between these models, but all software, once you start making software, it can change really quickly, and you can start off doing the waterfall model and end up doing a rapid prototype. You can start off with the intention to use the spiral model and end up just in an evolutionary model. So as I go through these, I'll give you different examples of software I know that have more or less fallen in one of these categories. So the first is the really theoretical one, and it's the one everybody likes, but nobody can quite do, and that's the waterfall model. The waterfall model is we just take the software through the life stages step by step. So at the waterfall model, picture different waterfalls and different pools, and then the one pool turns into your next waterfall, and the next one turns to that. It really should be called a cascade waterfall model. And so waterfall model just means we intend. We intend to start out validating it, not validating it, sorry. We intend to start out asking, is this a good idea? And then we specify it, and once we're done specifying it, we design it. Once we're done designing it, we test it, and then we evolve it if it's successful. That's the intention of the waterfall model. We just take the software through the life stages step by step, and each step's output leads to the next step's input, and it's like a series of waterfalls. Every software company I know starts off with this idea. Very few stick to it in the long run. Some examples of a waterfall model would be almost any business application. It fits the waterfall model. So Microsoft Word started out there, Windows started out there. A lot of early software started out with sort of the waterfall model. Another example with the waterfall model is a user approaching someone and asking them to make the software for them, and then there's a conversation about whether it's feasible, and then you take it through the stages. So that's the waterfall model. Its strength is that it's well planned out. But its weakness is plans fail pretty quick. In fact, one of my favorite quotes, Winston Churchill said, "Planning is essential, plans are worthless." And so waterfall is planning, and it's essential that you plan. And so that's the really good thing there. Its weakness is it's just completely not feasible. The best of intentions fall apart pretty quickly. So the next one is the evolutionary model. This skips your feasibility and specification stages. And so the evolutionary model, we don't bother asking, is this a good idea? We don't bother planning it out. We just go right to writing the program. And then as we write the program, then we find its feasibility and its specifications. And so you skip those stages, but you kind of do them while you're doing it. So last year, I started to make a website for you guys to use, for all my classes to use, one website where all my classes could go to and get their homework. And I didn't really intend to do that. I just started playing around with HTML and CSS and JavaScript and seeing what I could learn. And I actually started out doing something entirely different, but as I sort of was learning, I stumbled into making this website for my classes. I'm never sure at what point I decided that's what I was doing. It just sort of, the website I was making just sort of turned into that. And so that's the evolutionary model. It's usually nobody has asked you to do it. You're just sitting around, playing around, and suddenly you realize, okay, I'm building a house, or I'm building this website, or I'm building this video game. And so a lot of independent video gamers, not the big AAA companies, but a lot of the small-time people who just buy a software end up stumbling into a video game. Some of them have made a lot of money. A classic example of the evolutionary model is Minecraft. The two guys made it in their dorm room. Facebook would be another great example of an evolutionary model software. Nobody sat down and decided this is what we're going to do and this is what we're going to specify. They just made a little website, or they made a little game, and then it turned into a big game, right? And so you continue to fix and tweak it before releasing. And so that's the key there. It's just playing around and seeing what's there. It is different from the next one, the rapid prototyping. Really quick, a prototype is a dumbed down version of a program. Rapid prototyping then is we build a really quick prototype and give it to the users. And so rapid prototyping would be if I took my website I made last spring and I just released it to all of you without even finishing it. And I just said, hey, what do you guys think about this? And I give it to you guys, my students, since it was made for you guys. But then here's what makes rapid prototype work. Obviously, if I build a quick video game and give it to people and it's a stinky video game and I never talk to people again, then they just think that's the worst video game ever made. What makes rapid prototyping work is I stay in contact and get feedback and then fix it. And so rapid prototyping would be I release the website and then you all look at it and you say, here's the things we didn't like, here's what we didn't understand, and then I get your feedback and I come back and I fix that and I release another prototype to you and then I fix that and give another prototype to you. So that is rapid prototyping, different than evolutionary. Evolutionary is I don't release it until I have something good. Rapid prototyping is I just release it. I just say, what do you guys think about this? And then you all jump back at me and say, here's what we think, here's what we like, don't like. So that's a key difference between the two. And then we have the incremental version. The incremental version is different from the last two. And that is we intend to release parts of the software in pieces. So right here, think about your tablet games. Most tablet games now are incremental. Any tablet video game that has chapters, now they will release a chapter of a video game, and they'll say this is chapter 1. Notice it's not like rapid prototyping. Chapter 1 is still polished. It's still cool. It still works really well. It's still a fully developed chapter. Maybe a few, character typos here and there, but it's still a fully developed phase, but it's not the whole program. And so I give you a piece of it, but a finished piece. Whereas rapid prototyping, I'm giving you the whole thing, but none of it's polished or finished or good. Incremental, I'm giving you a finished piece, and then I'll release to you another finished piece when I get it done, and I'll release another finished piece when I get that piece done. There was a video game company that actually went bankrupt a year or two ago called Telltale Games. They released their video games that way. They released chapter by chapter by chapter. And now that they've released all the chapters, I can buy all the chapters, but if I was buying them as it came out, I would have to pay $1 or $2 per chapter. So that's an incremental model. I finish one phase or one piece of it, I completely finish it, release it, completely finish the next piece, and complete it. And last but not least, we have the spiral model. A spiral model is I do a quick pass through the waterfall, meaning I still do all the steps. I still ask, is it a good idea? I still specify it. I still put it together and test it. But from the very beginning, I intend to start back over with the intention of adding new features with consecutive releases. And so I put together, it spirals kind of halfway between a rapid prototype and a waterfall model. And so it's just a little bit less rapid. And so I still give a good polished program, but right at the beginning, I have an intention to add more features to it and do more releases. I guess an example of this, keeping with video games, is DLC. And so downloadable content in video games, and so they make a full video game, but then they release another feature. They release a DLC, and the DLC goes through all phases of the waterfall, but they intended to do that from the very beginning. So that is your spiral model. And so that's a little bit about the life stages of software and about how different companies and different groups of people might put software together. Next week, we'll talk about the nuts and bolts. Next week, we'll talk about how this is actually all done and some of the key important things while you do it. So don't forget to reply below in the comments to this with a question or a comment and let me know what was confusing or what helped you or some thoughts about it. And I'll release a tutorial for how to do your assignment this week as well. We're almost done, guys. I still miss you, but have a good one.